And our speaker is Lucas. Did you want to try to put on the mic? Or? Yeah. There you go.
By the way, the pizza and the drinks are not sponsored by St. Dine Spaces. They're sponsored by Dave and the, what you guys probably all know, the South Florida Code Camp, which happens once a year, already happened. If you don't know what about it, where you been, welcome to Florida.
How about now? All right. Cool.
We've lost the slides.
No, that's all right. I know where they are.
I am recording this, guys, but you'll much better being here. Here you can ask questions. It'll be on the comments of the recording.
Everything good? Everything. All right. My name is Lucas Vogel. We're not going to go into the full hour and a half, just in case anybody was really looking forward to that. It's probably going to be about a half hour. And I'll tell you up front, the big reason for that is because I didn't get half the stuff done that I had to do for this, because I outscoped myself and then I ended up completely ass backwards and then I had to hustle. So I'm going to spend a lot of time talking about why this is important or why I think this is important, share my story about it with you. I've been working on this stuff for almost 12 years now, which is kind of crazy. And see if we can find some common ground for where you guys might want to use it somewhere. I think there's a lot of tremendous potential for this, especially in today's environment. So I started this company back in 2007. I was doing a lot of BizTalk consulting. I've been doing .NET development since it came out. BizTalk came out shortly after that. And I've been working on both pretty much the whole time until the last 4 or 5 years. Before that, I was doing Visual Basic WinForms development. I was pretty good at it, but that was a couple lifetimes ago. One of the big things that I really was looking at when I started this was, you know, at the time, this was the mid to late 2000s, and there was a lot of discussion at the time about Unix technology and how there's all kinds of innovation happening on the Unix platforms, you know, Linux and otherwise, and what is the .NET community doing to embrace and extend that in its own right? And the answer didn't really seem to be much. So I started taking a look at it, and I stumbled upon the platform. Is it me? Oh, okay. So, anyways, I started looking at this, and you know, this was before JavaScript became the all-encompassing platform that it is today. So XML was still pretty popular at the time. If you're familiar with BizTalk at all, everything is XML inside of it. So I was doing a lot with XML, and I found the Berkeley Db XML database. I'll talk a little bit about that down the road, but at the time it blew my mind because it was the exact same data structure that a BizTalk message is. It's an XML message with a metadata payload that sits on top of it and gives you all the context about the message. And it's a perfect for this database engine. So I was blown away by it. Started working on it and building it out so it would integrate with the .NET framework. Anyways, we'll circle back to that a little bit later. But I really spent a good 3 years or so working on that, building the C++ wrapper library for the 4 or 5 C++ DLLs that sit underneath it that really make up that product. And then drove myself completely insane trying to manage everything else. So I guess 2007 was my first foray into product development and really coming to understand and appreciate how absolutely difficult that is. It's insane. So it's 2008. We're all doing cloud stuff. Cloud stuff is where it's at. It's where the cool kids are. I focus a lot on APIs, building web apps, doing data integration. My favorite framework is the Nancy web framework. It's pretty great. But I'm increasingly doing a lot on .NET Core and spending a lot more time on the Unix platforms with it. I feel like we're kind of in a weird place with .NET as a whole, where Windows doesn't seem like it's as prevalent as it used to be. Our base isn't necessarily shrinking, but it's not growing either. At the same time, we've got the .NET Core framework out there. We've got portability into the Linux platform, and it's open world for all of us. And I mean, I'm not very good at these predictions, but it seems to me like we're going to end up spending a lot more time on the Linux platform than we are anywhere else. So it's as good a time as any to get used to it and learn to adapt and integrate with all the other products and technologies that are available out there. And there's some really cool stuff. I can tell you firsthand as a .NET guy, I've been blown away by just going through the Apache catalog, for example. Anyways, HIPAA compliance, and we're also focusing on Berkeley DB as a whole. It's an Oracle product, and it's one of those things where it's kind of in a real middle of the road kind of place. It's an Oracle product. Oracle has a ton of products. They have a ton of database products, and this engine that kind of ran MySQL for a while, and they bought them, but they don't do anything with it other than they've got a product called the NoSQL database that it's built on top of. So we'll talk about that a little bit more too. Other thing I'm doing is I'm actually using this stuff. I'm dog fooding it with a project that I'm doing called the Stillhouse project. I'd like to come back in about 6 months and actually show you guys a real world demonstration of this stuff, because there's a lot to it. There's a lot of layers of code inside of this. Anyways, I'm going to have a microservice framework set up using this as the data store for basically stuff about booze. So it should be entertaining at the very least. So kind of going back to the whole story about the databases, everybody uses a database server for everything these days. You can't install most CMS platforms without one. Like you can't go spin up a WordPress site without at least some kind of MySQL database running on the side. And I think it kind of goes without saying that Microsoft has I think they've successfully plugged SQL Server into everything. And I mean truly everything. And the fact of the matter is that it's okay, but it's overkill for about 80% of most things that I've seen people working on. You know, unless you're doing a lot with the business backends that require all of that, you don't necessarily need it. I especially don't think you need it for most web apps and most APIs / microservices. Even if you're just taking data out of an existing relational database and keeping a subset of it somewhere for your resources to access quicker, I think it's far cheaper and more preferable in many ways than having this big ass server sitting over here that you're paying for with all the network traffic, with all the resource contention, when all you had was the one app that needed the one thing or the two things. So it's overkill for just about everything. So I guess a good slide would have been, what is an embedded database? Embedded database is a database engine that's literally just a DLL that sits inside of your app. That's it. It puts together the database file for you. Obviously, you pass in some parameters for that. You configure everything that you need for your database engine. So, for example, you can set up an in-memory database. You can set up a database that replicates to other locations, talking to each other through TCP. You can do things like that. You configure everything inside of your application. It's a double-edged sword because you're configuring everything in your application. But generally speaking, for most apps, it works out just fine. You can build something with a schema, or you can go completely schemaless and just persist your objects as you go along. I've got some demonstrations for that. It reduces network traffic because you're not calling this other server that sits somewhere else. Everything is done on the spot inside of your application. And it's pretty simple. There's no object relational mapping library. Mapping data type A into the relational data store type that sits over here. There's no going through the motions of the ORM and like the entity framework in particular. And to me, that's a godsend because I hate that crap. So Berkeley DB has been around for over 30 years. It got started in the 80s. There's a guy by the name of Mike Olson who was a grad student working on it with a few other people during I believe it was the BSD days. My history might be a little off with the Unix histories, but it got its start in the BSDs. It moved into Linux, and it's been used in some pretty amazing stuff over the decades. The Yammer Platform, before Microsoft bought it, there's a guy by the name of Scott Kennedy. If you look him up, he gave a good hour or 2 hour long presentation about how he used this Berkeley database engine to build a data environment for Yammer, which I think is now all subsequently moved into Azure, but it was a pretty major undertaking, and it's a pretty neat story. So I highly encourage anybody that's interested in that kind of thing to go check it out. It is the package manager. It is the engine for RPM. If you're doing anything on Linux, everything gets put into a Berkeley DB database. It's all over the place. Security things use it inside of the OS. Before Bing, there was a I think it was Swedish or Swiss company called Fast Search and Transfer. That search engine ran on Berkeley DB. And you know, it's hard to get data on all of the things that have used it, but I've heard of a couple other Microsoft products that might have had it in there somewhere. Probably not necessarily anymore. But the Sleepy Cat company that owned it had it up until the 2000s. When MySQL became a major database platform, Oracle went after everybody that did anything with it in order to buy it out. And in the process, they ended up picking up the Sleepy Cat company and buying Berkeley DB. They bought a couple other database engines before finally buying out MySQL, but that's history, and now it's an Oracle product. Oracle took the database engine and built something called the Oracle NoSQL server. It's a rather large Java install, but it's basically just JSON data, whatever kind of data you want to stick in there, it's just going into this database engine. So they use it, they maintain it, but they're not going to actively advertise this. In fact, I think if Microsoft had something like this, and I think they do on Windows, they've got some kind of embedded database engine, they're not going to talk about it. So I took it upon myself to kind of sit between a rock and two large entities and decide that I thought people should know about it, and we should probably try to use it wherever we. So that's how I got into the foray of product development. Now, if you wanted to go and get this right now, what you have to do is go to the Oracle site, go to Berkeley DB, that you'll find it in there somewhere. Talks about embedded databases. And you can download the package. It's about 100 megabytes. And first thing you have to do is build everything, and then you have to build all the libraries that all of this depend on. There's just a couple of them, but they're pretty big builds. So it's out there. What I'm doing in particular is taking all of this and making it .NET friendly. None of this is .NET friendly in the slightest. Oracle has no interest in the .NET framework. It's Java, and that's pretty much it. So I'm taking this, I'm updating all the documentation, making it useful, putting C# examples in there. I'm also taking the library parts themselves and kind of normalizing those and expanding on things where it makes sense. But it's long work and it's fairly tedious, and I haven't gotten too far, which is why I'm a little behind today. So there's 4 different product editions. It really depends on what you're trying to do with the application. The simplest and the cheapest is called the data store. It's a single-threaded read and write in and out of the database. Next upgrade from there is the concurrent data store. You get more reads, but you still got the one write. The transactional data store comes after that. You get the transactional capabilities. You can do multi-threading. You can do your locks and blocks and all of that. Things get obviously more complicated the further down the road you go. High availability is built on top of transactional data store, and that gives you a master that you can write to, and then remote replicas that get updates of the writes. So it's pretty cool. The high availability part kicks in because if one of those goes down, you can configure your replication scheme so that another one becomes the master, and then it starts taking all the writes and pushing those out. It takes some architecture to implement correctly, but you can do it. You've also got hot backups for your data. You can start pushing things out and getting it off of whatever app engine you're running on. There's 4 different access methods. This is really what makes it pretty unique to the database. Well, I guess as a database engine, it's pretty unique. So the B tree is probably the most common. If you know anything about database engines, that's one of the most common ones you hear about, the B tree or the B plus tree. There's something called the hash, which is a little, it doesn't store as much metadata about your data as the B tree does, but it's really meant for when you're getting up to the terabyte level. You're hitting this thing all the time, and you're in a hot data scenario. You want to use something like that because there's less overhead and it's a little more efficient at that scale. That's really the only big difference I could find between the two. The heap is for actual bases. So one thing that I don't seem to have included is the fact that this has language extensions for everything. So it's C, it's C++, it's Python, it's PHP, it's Ruby, it's .NET. All these different platforms use it. And it's all across the different Unix platforms, Windows as well, and it's been put in all kinds of things. It runs in hardware, so in those kind of scenarios, that's where the embedded database part kicks in. So you've got limited space. You need to make sure that your resource constraints are there, so you use the heap. The queue is pretty self-explanatory. It's great for hardest presentation I've ever put together because it just falls to way too much, and then you don't put your demos together, and then you're not showing anybody anything. So it will read and write into just a regular text file in the back, so you can go and just look at the file and see what's going on. Probably not great for a lot of applications, but I mean, I could see a good number of web scenarios for it. So it does come in handy. Some of the different things that you need to understand when running your own database engine, you've got a memory pool where as you're doing your writes into the database, you're actually writing those into page files. Those page files getting flushed is what actually commits it to disk. It really breaks things into a fine detail on how you want this thing to behave, and that's where it gets really tricky. So you can set it up so that it's percentage of clean or dirty pages. You can load databases into memory, like I had mentioned. There's the transaction subsystem. You've got your ACID operations, you've got logging and locking, you've got your checkpoints and timeouts, and you can archive your database and your log files. Logging system, pretty self-explanatory, locking and replication. I'm going to show you some code that kind of goes through what that looks like. Probably better than trying to sit and explain it through the presentation, so we'll take a look at it. So it's a database engine. It gives you a very fine-grained control over how it behaves, which is why a lot of the solutions that come out of this, a lot of the enterprise-level solutions are the Oracle NoSQL database engine, which is just a huge man that sits on top of this. Their own goes on for 2 hours about all the things he had to tweak in order to let that thing run over 20 or 30 servers. It doesn't have to be that way. You can use it for just dead simple stuff. It just gets more complex the more your requirements grow. It's as simple as that. The database configuration, once you set things up, there's not much wiggle room for change. That doesn't apply to things like memory or locking numbers, but if you're going to open a B-tree database, it's a B-tree database. You can't turn it into a text file all of a sudden. They don't switch out like that. So for the .NET side of things, it's a C++ database infrastructure. All the code is in C. So there's a SWIG library that sits on top of all that, and then a .NET layer that sits on top of that. And that's how the SWIG is I don't remember what the acronym is, but it's basically the tool that's used to generate interface libraries for cross-language portability. So if you wanted to use this with Python, I think they've got something similar to that, where it builds out the stubs for Python, and it supports like 50 languages. It's pretty intense. Nice thing about all this is that it's Oracle code and not hand stuff that I had written, which I did a while back in this project. So like I was before, I started this 2007. I worked on it for about 4 years. I bring it up because I know there's at least a couple of you still doing XML. There's still a ton of it out there. This is it's a fantastic data storage for XML. It's got the API to it. It's also got an XQuery engine that plugs directly into the database engine. So you can easily convert your XML data into something else entirely, including JSON or CSV files or whatever you want to do with it. There's really no limit to the XQuery part. I'm really kind of surprised that it fell into the dustbin as fast as it did. Document metadata. And basically what I did was I built a C++ CLI wrapper for it. If you're not familiar with that, C++ CLI was Microsoft's way of integrating the C++ compiler with the .NET framework and the underlying the intermediate language. So, and surprisingly, they're not too happy with it. It's great. It's probably one of the coolest things they built, I think, but not very popular. Anyways, if you're interested, there's the URL for it. Things are in the middle of a big shuffle right now. Like I said, I'm working on the Berkeley DB stuff more. This is probably going to sit in my dustbin a little bit. Hasn't been a huge amount of demand for it. So, still a great product. So the roadmap on my side of it right now, I'm putting up a NuGet gallery as we speak. If you go on that link, you can actually go into it and register. If you have any interest in looking at this library whatsoever, by all means, do that, or just contact me. Let me know. I'm going to have some more links here soon on how to do that. But it's a great package. I'm going to put up some Docker images for it. I'm going to finish the documentation and do all these, not in this order. So let's take a quick look at what I did manage to get, and let's take the examples that Oracle gives us for how to interact with it. Let me pull that stuff up real quick. Yes. Yes, not an Oracle product. All right. No problem. So I've got in my possession here an ASP.NET Core app that I called orders, which actually doesn't even have orders now that I think about it. But what I do have is a data repository. And I got a little bit fancy with this because this is out of my documentation examples. And what I have is this. My base class is up here somewhere. Here it is. So I go through and I create a B-tree database. And essentially what I've got is I've got vendor data that I made up through some fake data website, generated a bunch of fake data, 50,000 records of fake vendors, and then for each vendor they get 5 fake inventory lines. So they go into 2 separate databases, and they're both B-tree databases, because that's what the documentation is doing that I'm translating right now. So in this little line of code, we're creating a config object for our database. We're saying create it if it's not already existing. We've got a cache size of, I think, 1 gigabyte and just 1 cache. I had some feedback there that would feed into the console. I don't think that's, well, I guess that's partially relevant to ASP.NET Core, but this should probably feed into maybe a web page, or it could go into App Insights, something along those lines. We've got an error prefix. That's basically for the feedback. And we have a duplicates policy. So if we have more than 1 record, I had this set up so that it would key off of the company name. And then everything blew up because the company name started repeating all over the place. So I changed that around for sake of brevity, but there is a way of handling that, and we'll take a look at that too. So I go and I open this B-tree database. In my repository, I've got to dispose. I'm dealing with C++ library, so I need to make sure I dispose of all my objects correctly. You would be surprised how many people don't do that. Or not surprised. I've got a function that adds data into the database. Now this is a database entry object, and this database entry object is literally just a byte array. The key and value both are byte arrays. It doesn't matter what you put into that byte array. You can put anything into it. It just has to be a byte array when it goes into the database for the well, for all of them. Here we've got our sync method. We manually sync our app, and this I also want to be kind of clear. This is like the data store version of the product. I'm not doing anything with environments as of yet. I'm not building replication anywhere. This is just a dumb website. It's a really dumb website, and it's just going to display some vendor data. So I don't need any of that here. And obviously, this could very well easily be an API. It could be anything with a web endpoint to it that pulls data, pulls and pushes data. So I've got a vendor repository that inherits from the repo. I've got a paginated list for a table I'm going to show you. I get a count of the records from the stats function, which gives me basically just a structure of information that it has about my database. So I can get how many pages it's got, how many dirty pages. If I go take a look at this, I got all kinds of info. I have DB. Now this is Oracle code, so it's not the friendliest, but they did manage to put comments in here too. So, well, they kind of did. Maybe I spoke too soon. But it gives you some pretty interesting info. This comes in handy when you want to fine-tune your database, which you inevitably will want to do. No. Shit. Anyways, so we add a vendor. We give the option of adding the vendor. Why is that? Moving right along. We do the same thing for some inventory. We have a repository manager down here, which basically is our reference that we pass around for anybody trying to get into the database. All this does is it takes two CSV files and breaks them up and puts them in the database. And that's all this code does. We can skip past that. Nothing new under the sun. At the end of it all, we flush all of the pages that were written. We flush it all to the disk. Very important. And then we move on. So let's see. That's really the bulk of the database code that I've got right here. If you go into our app data folder, we've got our CSV files, we've got our databases, and let's do this. I'm going to open this. So it's about 100 megabytes for this vendor. Wait a minute, no, vendor's 37, inventory is 100 from our 5 megabyte and our 14 megabyte files. A lot of metadata and other information getting stored in there. So let's go ahead and delete them, and we'll fire up this dirty ass site. We use our favorite web browser.
And then we go to our vendor page. Now we don't have databases yet, so while this is loading, what's happening is the controller that brings up that page fires off the repository and loads all the data into the database. So in between 10 and 12 seconds, we got our 300,000 records put into our 2 databases, and now we can play with them. So that's all there, and it just goes pretty quick. That's literally all I have on this demo, so that's why I felt bad. But the nice thing about it is I've got the example that I pulled this from, where I can go and look at some of the metrics. So let's take a quick look at that. The other thing about embedded databases, this is going to run as fast as your hardware is good. So I'm on a Surface Pro. I've got an SSD drive. I've got a pretty good processor. It's on full blast right now. The only thing this doesn't have that it usually has is I keep a Yeti cooler block on top of it, so it stays cool, because this thing will melt. Anyways, so I've got this code for this project, and it basically does the exact same thing. So we're just going to take it, we're going to delete our databases, and we're going to run it. It's in release mode. And then we're going to take a look at some metrics. So our average write time was about 338 ticks. There's 10,000 ticks in a millisecond, and it gets slower towards the end of it as you're building up all the data. So our fastest was 190 ticks, about 800,000 ticks right there. So we got into a few milliseconds. Not bad. I mean, it's fast. Again, I mean, this is my laptop, and we're running in Visual Studio, but you know, there's no reason that you couldn't get that from comparable hardware somewhere else, and not running in Visual Studio, for crying out loud. So that's no optimization. That's not looking at the OS. That's not fine-tuning anything in the engine. It's not really doing a lot of anything. It's just reading the data. Now, if I want to query that, I've got 2 options. I can open up a cursor, and let me show you the cursor. I might not have it in this one. Pull up the other one. In fact, I'll pull up 2. So the other thing that I didn't show in the last one is that you can open up a cursor on your database, and the cursor is exactly what you think it is. It's a position in the database itself. It's a linked list, so you can do link operations on it and query whatever you want out of it. The only caveat is that it's all linked lists of binary data. So that's where the secondary database comes into play, and I think I took that out of this one. So right here I've got a cursor. This is commented out because I open it and close it, but the cursor just runs from end to end. If you want to index your databases, you create what is called a secondary database. The secondary database really doesn't look any different from the regular database. It's a key value store. You can store it inside of the same database file, or you can have a separate thing for it. So it's really, it's an optional feature. You have that level of control over it. Secondary database gives you vendor IDs, for example. So the key vendor ID value will be whatever has that vendor ID. It's pretty simple stuff. I know I'm repeating myself, but fairly straightforward. Let's take a look at the built-in examples that we have from Oracle themselves. And see some slightly more advanced configuration. So this example right here is a bulk insert, basically just bulk operations. So you're taking X number of entries and you're putting them in there. They're all duplicates, so they get a slightly different setting when they go in. If we take a look down here, we're doing a bulk read. And bulk delete. So yeah, this is just doing it out of the app itself. We got a transaction. We start that up. It looks like we go and get our list of data entries. Well, I don't think I could explain this very well from here if I wanted to. So I'm not. As I mentioned, it only gets more complicated from there. If you have an interest in it at all, by all means, please let me know. I've got a Slack channel open. If you're interested in checking it out, if you're interested in hearing more about it, if there's anything that you're interested in it at all, don't hesitate to give me a shout. The demos that I am working on are partially on GitHub at the moment. They'll get there further as I go along with the documentation. Documentation on GitHub as well, if you want to take a look at that. Come find me on Twitter, whatever you want to do. And that's all I got. I haven't. Oh yeah.
Go ahead.
Yeah, you can
repeat it again.
Have you ever tried loading data or feeding data or pulling data from that using like SSIS was my question.
Yeah, no, I haven't done it, but because it runs in your code, you could literally plug it into your code and just do it that way. Yeah, absolutely.
Probably the same thing with reporting, like using SSRS or another tool like that. You could connect to the database and.
Can you put it big? It's hard to see. Sorry, my friend, I'm interrupting you.
Yeah, it's very rude, by the way. That was the only other question I had.
Is that the one? Does that one work? All right. That should work. It's all the same links.
So it's your Slack, or is like the Slack of the group?
Oh, that's my Slack.
Oh wow. Am I wrong? Is the original Bitcoin client on Berkeley DB? I think. Maybe I'm wrong.
I haven't heard anything about it. It wouldn't surprise me.
Yeah. So that's what I was like. Yeah, I know that.
Yeah. No, it's ubiquitous. It's been on the Linux platform since it's been out. All the other languages have used it in various applications. The language extensions have been there forever. We're just getting to the party. Well, this has been around for a while too. So I'm really just kind of telling you guys about it because I set it up so that you can use on the .NET Core, and now you can use .NET on Linux, so now you can use it. The other thing too, and I don't know if I mentioned this, is that let's say you are using it with C#, but then you've got like a Python application that you need. It's got to pull something out of that. You can switch over. They're fully compatible with each other, and you can do that kind of thing with it. So, or you can throw an API in front of it and make everybody do it that way. I mean, the possibilities are endless, and that's the beauty of it. So.
I see there's a number of parts of it, like a data store, a transaction. Can you just use the data store?
Yeah.
Okay.
No, that's all I used for that website, because it was just the simplest. But if you want to get sophisticated, you'll create a database environment. The database environment, you can configure logging, you can configure your temp drive, you can configure all these things, and it's really just the folder. But as soon as it knows that that's where it's at, it picks up everything it needs to out of that and starts going to town.
Then I was looking at it, I realized I know Margot Seltzer, one of the developers of this.
Yeah, Margot was the CEO, I think.
Yeah, up in Boston.
Yeah. Mike Olson, by the way, is the CEO of Cloudera. Okay. But he was on.
He was the third one.
Yeah.
It was Margot, Keith, and
Yeah.
Mike, right?
I think it's Mike.
Is it because you're a Microsoft MVP and have been for the last 25 years? Is it because you know everybody in Microsoft because you're the Microsoft MVP?
That's not anything to do with Microsoft.
You know everybody in Oracle too? I have friends up in Boston.
Lucas, I got a couple questions for you.
Sure.
The first one is, what projects or what kind of applications have you actually developed that uses this?
I'm in the middle of building a microservice platform with it for a project that I'm just getting started on. I'm actually doing.
But I mean, what is it? I mean, can you give us a little? Tell us what it does, or what kind of industry?
It's a jukebox for liquor. That's about as good as I can explain.
A jukebox for what?
Liquor.
Oh, for liquor. Okay.
Yeah. Jukebox. Basically.
So it's like a website?
Yeah, it's basically just looking up information. Like, let's say you go to what's the name of that package store? It's got everything in it. Total Wine. Go to Total Wine. I do this all the time. I go to Total Wine. I want to drink something, but I have no idea what the hell I'm going to drink. So it's basically kind of a way to help you figure that out.
Okay.
Yeah. But I'm going to use this database engine for it and build it all out. So.
My next question is, do you know of any bigger companies that are using this and what they're using it for?
I don't know any more than the Wikipedia page. Oracle doesn't share that info with me. And
well, that's what I'm kind of trying to get at was, who's using this and what are they using it for?
I can tell you I got contacted last year by an IoT firm in Canada. And it's a big name, but I don't remember the name. I can look it up. But,
so it's an IoT application they're using this?
I mean, there is an IoT company that was interested in it. They never got back to me on anything, but it wouldn't surprise me actually if they just went to Oracle directly. But I can tell you that it's embedded in some hardware. There's a number of people that use it for literally embedded things. But yeah, I mean, Yammer, that was really one of the big ones, the search engine. But those were 10 years ago. So who's using it today, I couldn't tell you.
Bitcoin Core.
Bitcoin Core.
The original Bitcoin client was on Berkeley Db.
Was it?
Absolutely.
Okay. So
The original Bitcoin? You said the original Bitcoin used it?
The original Bitcoin client was using this as its internal database. So
yeah.
you become one file, it gives you
Right. Yeah, I mean, I guess the point I'm really trying to make is that it's almost by default that we spin up these machines and we put everything on the server. We've been doing server-side everything forever. The cloud is built for server-side everything, and I don't expect this thing to really take off, but you can literally use it anywhere. And all I'm really trying to do is just let you guys know, let anybody know, build some demos so I can actually demonstrate it. But yeah, I'm honestly kind of surprised that it's so hard to find these other things. Now, if you dig into the Linux platform itself, you find it all over the place. All the RPM files are databases. It's almost like a zip file on Linux. It's almost that ubiquitous. I know some of the system internals, like the etcds, some of those use it or used to use it. It used to be a database engine for MySQL at one point, not a popular one, but I mean, it's there.
Okay.
I mean, right. I look at it too as like it's one of the pet peeves I have as I get older as a developer is just the way things are supposed to be one way, but they always never quite seem to be that way. And like this guy knows, because I love to bitch about JavaScript and how JavaScript has just taken over everything. And you know, in many respects, it's fantastic because it's revolutionized the user interface. But it's also become kind of like a lazy data structure for search engines. Like now you're expected to just inject all of your JSON data structures for the search engines to just pull that out, as opposed to doing it the hard way and using the micro HTML and all those things that were in place for that, you know, specific purpose of keeping the size down. But we're also supposed to keep the size down, if you didn't know that. And I mean, in my mind, this is kind of like a no-brainer for that. If I'm building APIs for anybody, this is my first choice because it takes out the need for that. Now, it's not free, but if I use the data store version, it's cheap. I can license it on a 1-year basis. I can license it for 2 or 3 years. I can get a perpetual license. I can get an ISV license if I built something that I want to redistribute to everybody. You know, the possibilities are endless. And I mean, I've seen it on some of the older apps on the Windows platform where people like have the low-down SQL database engine running somewhere, where it's like, do you really even need it? I don't think you do. Maybe some of the accounting apps or something like that where you need a few columns, but I still think it's overkill. I think that's why MongoDB has taken off and now is trading publicly. By the way, I don't know if anybody's ever heard of MarkLogic, but they're making a fortune off of all the XML that nobody wants to do anymore. Like it's just ironic. So there's definitely a need for that. By the way, speaking of MarkLogic, all the people that used to work on the Berkeley Db XML engine all work at MarkLogic. I don't know if that's even relevant anymore, but I found it interesting. And they're doing the same thing. A lot of these things are just repackaged embedded databases. They're just building the layers on top of it and customizing it to a particular niche. That's all they're doing. So this is the raw material for something like that. And granted, for most people, it's probably overkill. I mean, inside of a corporate environment, data store, yeah, sure. I don't know if I would build like a custom data platform inside of an enterprise. God bless them, but most people in that group, they wouldn't know the first thing about how to take care of it. So it's not the right solution for everything, but I think for a lot of the ideas that we've got, I think my idea is a great idea for it. I mean, I'm storing data about booze. I'm going to store stories about booze, some ratings. I'm going to get, you know, anything I can about each brand. I could put it in a MongoDB database. I could put it in Data Store. I could put it in Cosmos. I could put it in any of those things. I could put it in SQL Server. But I also want to, it's also got to be super fast. And I also want to keep the data to myself. So I think keeping it in my microservices that are encrypted, I didn't mention the encryption capabilities, but you can encrypt your data and it's mine. And you know, for something like that concept that I've got, if I'm going to go collect info on every brand out there, like I'm not sharing that with anybody unless you're paying me. So I need those things. I need it kept private. I need it kept to myself. So it's a whole new world out there. We're all going to be Linux developers someday. I like to think of this as just kind of, it's the first wave. It's happening. I mean, we're all going to see each other at the Python group someday or one of those things and shake our heads. So I'm just saying I won't be at the JavaScript one. Just FYI. Except for recruiting. I'll be there recruiting. So.
Thank you, guys. We do this every second Tuesday of the month. I don't mean to cut you off. Sorry, Lewis. Just wanted to remind everybody of that before they go. So that's it. That's all. Any more questions? Thank you, Lucas.
Take some stuff home. I don't want to take it home.
I'm going to leave it up for everybody else. Thank you, sir.
Yeah.